All right, welcome back, guys. We're going to be starting chapter 5. So both chapters 5 and 6, which are part of module 3, focus on statistics. Okay, so this is kind of like an introduction to some basic statistical ideas. Okay, so think about that word statistics. We've all heard it, and it may mean different things to different people. Okay, I've heard it used erroneously many times. In the statistics class that I teach, I actually give them a discussion post in which people can not so much lie, but create a false narrative depending on how they display those statistics or how they display that data. Okay. So anyway, the study of statistics is a whole complete branch in mathematics. Okay. And we're going to talk about it some, spend a little time on it. And in fact, similar to your finance project being the culmination of chapter 4, you are going to have a statistics project as the culmination of chapters 5 and 6. Okay, so you're going to be using some of these principles and concepts that we talk about. All right, so why care about statistics? Okay, what even is it? First of all, there's a video that I put in Blackboard for you to watch that gives a definition. Okay. But in fact, statistics affects our lives in many ways, guys, that we may not even be aware of. Now, in my live classes, I always ask my students, can you give me some examples? So I'll give you some here. Statistics are used in determining the warranty period for products, such as cars, televisions that we purchase. Okay. They're used in determining the rate for insurance, be it automobile insurance, homeowners insurance, health insurance. They are used primarily, that's how they determine those rates. Okay, they use statistics to assess how big a risk you are. Statistics are used in determining the safety and effectiveness of food and drugs that are approved by the FDA that we consume. Okay. So all those pharmaceutical drugs that we take, or you take, maybe, there are studies that are done on those drugs, and they use statistical methods to perform those studies and hopefully show that those drugs are safe and effective. Okay. And then statistics are used all the time in sports. Okay. That's, I would say, a very simplistic use of statistics. Statistics are used in weather forecasting, okay? So they are everywhere, guys, just like math. Math in our lives is everywhere, even though we don't see it all the time, okay? All right, so how does it work, okay? Well, it really has to do with trying to figure out, trying to estimate something that we don't know, or get an idea of something that we can never be 100% sure about. And so I'm going to give you an example here. I'll put this in the notes because we actually tried this a number of years ago. It's been a while, but at one time Pulaski Tech was in the position of having a football team. Okay, this was probably over 20 years ago, I think, and it didn't pass. Okay, but in any case, what if we were interested in knowing how the student body of Pulaski Tech feels about having a sports team? Well, you could say, well, can't we just ask them? Well, maybe and maybe not. How would we ask every single student at Pulaski Tech? We could send out an email, but not everybody checks their email. I know many of you guys don't check your email. Okay? So then what would we do? Would we try to find them on campus? Well, you might be able to do that, you might not. The point I'm trying to make is that it would be very difficult to survey and ask every single student at Pulaski Tech how they feel about having a sports team. Okay? And so that's kind of the motivation behind statistics. And so then we say, well, if I can't survey everyone, then what do I do? Because if the student body is not interested in having a sports team, then we don't need to pursue this. But if there is a lot of interest that could potentially generate revenue, then maybe it's something we should consider. Well, we rely on, here if you look in the notes, because, guys, it's almost impossible to survey what's called the population. The population in this context would be every single student who goes to Pulaski Tech. Okay, we have a lot of strictly virtual students that are out of state. They don't even live here. They just take online classes. Okay, so we take what's called a sample. Okay, and from that sample data, that gives us an idea of how the entire student body might feel. Okay, so the idea here is that the sample is representative of the entire population or the entire student body. Okay, so we might pick a few students. We might send out a survey, and of the students that do respond, we use that as our sample. Okay, now we'll talk about why that statistically may not be the best method. Okay, because it can create results that aren't necessarily reflective of how the population may actually feel. Okay, but anyway, because this is not a live class, I can't really show you this video. But we'll look at the actual definition here. So statistics is the science of collecting, organizing, and interpreting data. Okay, that's seems like a pretty simple definition, doesn't it? So we're working with data. We're collecting it. There's a whole science and methodology in how to best collect data. We're organizing it so that it can tell a story, hopefully, and then we're interpreting that story that it's trying to tell us. Okay. It's believed that statistics, or this idea of collecting and organizing data, began in Mesopotamia, okay, in the Fertile Crescent, and it was done. The motivation was to keep track of crops, so that those crops could be taxed, and to keep track of those taxes. So basically, record keeping was kind of the motivation here. Okay, or at least that's the idea. Statistics are used in healthcare. When somebody says that, if you're a smoker, you have an 80% chance of developing lung cancer. Well, that fact there, if you want to call it that, that comes from statistics. That comes from having collected all this data about smokers and looking at the incidence of lung cancer. Okay. All right, now that term statistics is used. It has two uses. The general use is this first definition, just simply the science of collecting, organizing, and interpreting data. The second is much more specific and very particular to the field. Statistics themselves are the data that you collect, the numbers or other pieces of information that describe or summarize something. Okay? So in the context of this made-up scenario here, the statistics would be the responses that I get. If I send out a survey, let's say my survey question is, how in favor, or how do you feel about Pulaski Tech having a sports team? And I give a scale there from 1 to 5. 5 being, oh, I definitely want it, and 1 being, no, I definitely do not want it. Okay, where would you fit in that range? And so the statistics would be the information from all of those surveys, would be all those numbers, okay, from that scale. And look at this bullet. Statistics is really about trying to best estimate some characteristic of a population, okay? So that characteristic may be how in favor students are of having a sports team at a college, okay? It could be which political candidate you're planning to vote for, okay? It could be how pleased are you with this particular product. It could be what is the average lifetime of this particular motor or tire, okay? And we do this by a process called sampling, okay? So we take a sample, and if we've taken the sample properly, then it will reflect the population, okay? And we'll talk about this more as we continue. All right, so let's look at these definitions. So the population, now when you see that word population, guys, don't think about the population of the U.S. like a count of people, okay? That's not what it necessarily refers to. A population in statistics or in a statistical study is the complete set. Now it could be people or it could just be things that are being studied, okay? Now the population in that example that I used earlier would be every single Pulaski Tech student. Not every single student, just every single student at Pulaski Tech. Or another example would be, let's say we're interested in buying a new tire. And we know what brand we want. We know the tire that we want. And so one of the specifications of this tire is that it has an average lifetime of 50,000 miles. Okay. Well, that came from a sample. What happened is there were some of those tires that were sampled. They were used, and it was found that on average they lasted 50,000 miles. Okay. So the population in that case would be every single tire that is made, every single specific tire that you're thinking about. Okay, that would be the population. So the population doesn't have to apply to people, or reference people. It could be a population of, I don't know, cardiac statistics, okay, or outcomes of a certain cardiac procedure. So anyway, all right, let's look at this next definition. The sample, okay? So a sample is a subset of the population, okay? So it's going to be a group within the population. So think about selecting a few students from the entire Pulaski Tech student body. Or think about sampling a few tires from all of the tires that have been manufactured, that particular brand and style, okay? So a sample is a subset of the population from which the raw data is obtained. Okay, so in statistics, we're interested in taking samples. And we look at the data from that sample, and we do some math with it, and we let it tell us a picture, okay? And we can use it to make decisions later on or determine trends, okay? All right, so now, population parameters are specific numbers of interest to researchers that describe certain characteristics of the population, okay? So a parameter pertains to a population, so you got to remember that. Now contrast this to sample statistics. Sample statistics are numbers describing characteristics of the sample found by consolidating or summarizing the raw data collected from the sample. Okay. So what I want to point out here is that we use these sample statistics to try to give us an idea of what the population parameters are. So we might be interested in figuring out what the average height of an 8th grader is at this particular school. Okay. So instead of having to measure every single 8th grader, we pick a few 8th graders. So we take a sample and we measure those 8th graders in our sample. and we find the average. So that average is a sample statistic because it came from the sample. But the parameter is the actual average of all the 8th graders, okay? The population in that example would be all 8th graders at this particular school. Okay, so parameters pertain to populations and statistics pertain to samples. You got to remember that. All right, so let's continue. So yeah, what if we were interested in determining what is the average height of all U.S. adult women? Okay. Do you think it would be possible to measure the height of every single U.S. adult woman? No, that's impossible, okay? It would be impossible to do that, so therefore we collect a sample. So we pick a few U.S. women, U.S. adult women, and we try to pick them in such a way that they reflect the actual population, okay? So I wouldn't go out and just pick all 30-year-old women, because the population of U.S. females doesn't just consist of 30-year-old women. It consists of a range of ages. Nor would I pick women of a specific ethnicity either, right? Because we're a hodgepodge of ethnicities. So I need to try to make sure that my sample is reflective of my population. And then what we would do is we would find the average height of the women in that sample. And we would use that sample statistic to make a generalization about all U.S. women, okay? And it says if our sampling methodology is good, then this sample will give us a good picture of the actual average height of all U.S. women, okay? So anyway, that's the idea, okay? All right, so let's look at a few examples here. This is a little longer section. There's a lot of definitions and concepts that we have to learn. Okay, so I'm probably going to do it in 2 or 3 shorter videos. All right, well, let's look at this example 1. It says identify the population, sample, population parameters, and sample statistics of the following. So it says in an account temp survey of 150 senior executives, 47% said that the most common job interview mistake is to have little or no knowledge of the company where the applicant is being interviewed. Okay. All right. So let's start with the sample. The sample is the actual 150 senior executives that were surveyed. Okay. Or it's the responses from those senior executives. It's not them themselves, it's their responses. So I'm going to use the word response. So the responses from the 150 senior executives. Okay. Now the population would be the responses from all senior executives. Well, as you might imagine, it would be impossible to survey every single senior executive, okay, of all these different companies and firms or nonprofit organizations, okay. But that would be the population. So what we do is we find a sample of 150 senior executives and we ask them, okay, what's the most common job interview mistake? And they said, well, 47% said that it was having little to no knowledge of the company that you actually want to work for. All right. So the population parameter would be the percentage. Well, let's do the sample statistic. The sample statistic would be the 47%. Okay. The fact that 47% of the time, the most common job interview mistake is having little to no knowledge of the company that you want to work for, okay? So we'll say no knowledge, okay? And then the population parameter would be the actual percentage. Okay? The actual percentage of senior executives that say that having no knowledge of the company where an applicant is applying is the most common job mistake. Okay. All right, so let's look at this next bullet point here. It says it is of utmost importance that our sample be representative of the population. Okay, that is so true, because if it's not representative of our population, guys, then we can't make generalizations about the population. Think about the presidential polling. When you see those presidential polls, and they may say, I don't know, I'll make up some numbers here, 51% of all of, whoever's been sampled, because they can't sample everyone. Typically, these pollsters will pick groups of about 1,000 individuals, okay? And they try to do it in such a way that it's reflective of the voting population, which would be, the population here, okay? And the statistic would be that 51% favor a specific candidate, and then 46% favor this other candidate, and then 5% are undecided or had no comment. Okay, so those would be the statistics. But as we've seen in the past, presidential polling or pollsters have been wrong, and a candidate has been elected when it wasn't actually projected by the polling organizations. Now, there's more to it than just that. There's something called the margin of error, which we'll talk about later on. That does have something to do with it. But lots of times, guys, those erroneous results or sample statistics come from poor sampling methods, inadequate sampling methodology. Okay, I'll give you an example. In 2016, when Donald Trump won his first term as president, it was Donald Trump. He was the Republican candidate, and then Hillary Clinton was the Democratic candidate, and every single polling organization predicted Hillary Clinton to win. But of course, we know that's not what happened. And so, some explanation behind that was that most of the polling is done in urban areas, okay, because that's where most of the people live. It's easy to have access to people and ask them, hey, which candidate do you favor? But a lot of Donald Trump's supporters, now, there were a lot that lived in urban areas as well, but there were also relatively more individuals that lived in non-urban areas, or in other words, rural areas, okay? And those areas weren't really sampled, okay? And so that's why the results from that particular election were a bit surprising to a lot of people. Okay, but anyway, that's just an example of how poor sampling methodology can paint an inaccurate picture of reality. All right, so let's look at this next thing. It says, why wouldn't you want to try and determine the exercise? Oh, no, why? Yeah, why would you not want to try and determine the exercise habits of all adults by only surveying gym goers? Okay, I typically ask my classes these. And the reason is, guys, because if you're trying to figure out the exercise habits of all adults, we know that all adults don't exercise. In fact, probably a minority of adults actually exercise consistently. And so if I only sample people coming out of the gym, then that's going to make it look like everybody exercising. That's not the case. And so my error there would be in who I'm choosing to be part of my sample. So that would give me very biased results there. All right, well, let's look at this next definition. This is very important. A representative sample is a sample in which the relative characteristics of the sample members are generally the same as those of the population. So, for example, if I'm trying to determine some population, or excuse me, some characteristic about a population, the population of people in the U.S., then I need to be sampling people of all backgrounds, right? Because those are the people that comprise the U.S. I don't just go and sample people in a specific age group or people in a specific socioeconomic class, okay? Because that's going to give me inaccurate results, an inaccurate picture of the population at large. And that's why a lot of statistical studies are not believable, cannot be trusted. And it's because the sample was not representative of the population. Okay. All right, well, let's, yeah, let's keep going just for a little bit longer. Let's look at, I think we're going to stop when we get down here to the types of statistical studies. All right, so how do we go about finding or choosing a representative sample? Okay, that's the million-dollar question. Okay, so to ensure that one obtains a sample that's representative of the population, we commonly use some of these different methods that we're going to look at down here. Okay, so the first method, and this is one of the most robust methods, and it's referred to as simple random sampling. Okay, and what this is, guys, it just means that any given individual or element that could potentially be part of a sample has just as much chance of being part of that sample as any other element or member. Okay? So in other words, we choose a sample of items in such a way that every sample of the same size has an equal chance of being selected. Okay? So we're introducing this idea of randomness. No one member or individual is more likely to be selected than any other. Okay? And this is one of the most robust sampling methods or types of sample, is a random sample. Okay, and then we have this other one referred to as systematic sampling. So what happens here, and this is typically done when you're sampling, this might be done by a manufacturer that's trying to figure out what some of the characteristics of a product that this manufacturing company is making. So what they do is they would pick products that are coming off the assembly line, or products that are being produced, okay? But they do it in such a way that they're picking every 10th or every 50th or every 100th product, okay? So it says we use a simple system to choose the samples, such as selecting every 10th or every 50th member of a population. So, you know, let's go back to that tire example. If I produce this specific tire and I'm trying to figure out the number of miles for which I need to warranty this tire, then I want to know on average how long is this tire going to last before I go ahead and make a warranty, right? So what I might do is I might select every, 1,000th tire that's produced. And I would test it and see how long it lasts. Does it last 40,000 miles, 45, 50,000 miles? And I would do that for many tires, okay, selecting every 1,000th tire. And I would collect that data and I would find the average lifetime of that tire. And I would use that statistic to inform me on determining that warranty period. Okay, so for example, if the average lifespan of that particular tire I find from my sample is 50,000 miles, then I might just go ahead and I might warranty that tire to last, at least 45,000 miles. Okay, that means I can be reasonably sure that the majority of the tires are going to last beyond the 45,000 miles, because the average was 50, okay? Now, we don't really talk all that much about how to determine that in this class, but anyway, this could also be, if you're taking a survey, it could be like surveying every 50th member, okay? All right, the next methodology, this really isn't a methodology, and this is the one you want to stay away from. It's referred to as convenience sampling, and that's exactly what it is. It's choosing a sample that's convenient, such as people who happen to be in the same classroom, okay? Or if you're, I don't know, trying to figure out on average how much is a family of 4 spending at the grocery store each week, going to Dollar General and only surveying people at Dollar General might not be a good idea, okay? And the reason is because, it could be people of lower socioeconomic class that tend to shop more at Dollar General. I'm not saying that's the case because I don't know the statistics. But I'm just saying that, that would be convenient, but that may not yield the best sample that's representative of the population. I might sample some people from Dollar General, some people from Walmart, some people from Whole Foods, etc. All right, let's look at the next one. Stratified sampling. We use this method when we're concerned about differences among subgroups or strata, okay? When I hear that word stratified or strata, guys, I think of geology. You've ever taken a geology class? If you're driving and there has been a cut in a hillside, you can see the strata. So those are like layers, okay, or partitions in the earth or in the rock. So you divide the population up into subgroups or strata, and then we first identify the subgroups, and then we draw a simple random sample from each of those subgroups. And then the total sample consists of all the samples from the individual subgroups. So I'll give you an example here. Let's say I want to try to figure out what the median income in Arkansas is. Well, the population in Arkansas is not evenly distributed. Most people, majority of the population in Arkansas lives within the metropolitan area around Little Rock, or they live in the northwest, up around Fayetteville and Bentonville, or possibly more up around Jonesboro. Well, there's a lot of area in Arkansas, and the population density gets rather thin. Okay, so what I might do, we know Arkansas is subdivided into counties, and I believe that there's 70 of them. So what I could do is, those 70 counties could comprise all of my strata or my subgroups. And then from each of those counties, I could pick a simple random sample. Okay, so that would be an example of stratified sampling. All right, so let's look at this last example. Okay, and I think that we'll quit right there for this first part. It says identify the sampling method in the following studies. So number 1, it says chosen at random, 500 rural and 500 urban people age 65 or older are asked about their health and their experience with prescription drugs. Okay. Now, at first sight, I would think, well, the word random in here means this is probably a simple random sample. And that's actually what I'm going to go with. However, I want to point out that this could also be stratified sampling. Okay, because what we have done here is the population that we're considering is everybody that's 65 or older. And then what we have done is we have divided this population into 2 strata: rural individuals and urban individuals. And we've taken a random sample from each of those 2 groups or subgroups. Okay, so I think this one could really go either way. But, actually, I'm going to say random sampling slash stratified, because I really think that this is more stratified. This is an instance of stratified sampling. Okay. Let's look at number 2. Every 10th person entering a mall is asked to name his or her favorite store. Okay. So this part right here, that every 10th person, should indicate to you that this is systematic. Okay, systematic sampling is going to be every so many. Okay. So think about things coming off a conveyor belt. Number 3, soybeans are planted on a 48-acre field. The field is subdivided into 1-acre subplots. All right, so what I can already see is we are creating subgroups here, okay? And then a sample is taken from each of these subplots to estimate the harvest. So this is definitely stratified sampling. Okay. And then the last one, so if we were just to use each of these once, then number 1 would have to be simple random sampling. Let's look at question 4. Questioning students as they leave a university library, a researcher asks 358 students about their drinking habits. Okay. Well, okay, so the researcher is interested in the drinking habits of college students, probably. And so the way they're composing their sample is strictly by asking students that leave the library. Well, there are certain characteristics that students that typically spend time in the library are going to have versus those that don't really spend much time in the library. And so because of that, this is not going to be very representative. Okay? A lot of these students exiting the library, they may not drink at all. They may be very mature, very focused on their academic and career goals. Okay? But in any case, guys, this is an instance of convenience sampling. Okay? Because you're basically just standing there asking these people as they come out. Okay? So you're not really putting any work into the sampling process. All right, well, we've gotten about a third of the way through, so I think I'm going to stop there for